Okay, in this video we're going to be talking about similarities of polygons, ratios, proportions, and then we will eventually get to matrices later on. So ratios compares two quantities using division is our most common one. Okay, so we could also use words. So find the ratio of the number of boys to girls in the classroom. In words, 3 girls to 4 boys, with colons, 3 to 4. As a fraction, 3 over 4. So there's different ways to write ratios. We see them in all of these ways. Okay, so simplifying these ratios, if they are yards to yards, I've got yards on top and bottom, so it cancels. 6 over 12, they're both divisible by 6. So I would get 1 over 2 left. My next one, I actually need to convert. So there are 36 inches in a yard. So if I times this by 36, I would get 144 over 18. And then since it would convert it to inches, my inches would cancel. And that would simplify to 8. My next one, there are 12 inches in a foot. So multiplying by 12, it would get it to 48 inches over 16 inches. Inches and inches would cancel. 48 divided by 16 would get me 3. Okay, extended ratios is having more than one number. So compares 3 or more numbers. So the ratio of boy giraffes to girl giraffes in the zoo is 3 to 4. If there are 35 giraffes, how many boys are there? Okay, well, it's written respectively, so it goes boy then girl. So my 3 stands for my boys, my 4 stands for my girls, and the total is 35. So that means if I add it, I could have 3x plus 4x equaling 35. Well, 3x plus 4x gets me 7x. Divide by 7, I would get 5, but I want to know how many boy giraffes are there, which stood for the 3. So I'm going to plug that 3 in. 3 times 5 gets me 15, so there are 15 boy giraffes. Okay, my next one, the measure of the angles of a triangle have an extended ratio of 1, 2, 3. Find the measures of each angle. I know all angles add up to 180 degrees in the triangle, and it has a ratio of this. So 1x plus 2x plus 3x equals 180 degrees to find the total. 1x plus 2x gets me 3, plus 3 gets me 6. Divide by 6, I'll get my x to equal 30, and then it says find the measure of each. So I now need to plug it in to all of those. So 1 times 30 gets me 30, 2 times 30 gets me 60, 3 times 30 gets me 90, and if I added all of them, it should equal that 180. Okay, a quality control engineer at a maker of microwaves found the ratio of defects to good parts is 1 to 20. So found the ratio of defects to good parts. So defect to good parts. If they make 200 good microwaves, how many can they expect to be defective? Okay, so I know I could represent it as a fraction, so I could do 1 over 20, and I'm going to match it on my other side. So it went defects to goods, so my goods was on my bottom. So that means I'm going to put x on top because I don't know how many. My 200 is going to match with my bottom. I can't add this time because I know I'm comparing from one to another thing. I'm not finding a total of something. Okay, so in this situation, we're actually going to have to cross multiply. So I'm going to multiply, it doesn't matter which way I start. I'll get 20 times x, drop my equal sign in the center, 200 times 1 will just get me 200. If I divide by 20, I'll get x equal 10, so there are going to be 10 defective ones out of that 200 good. Okay, proportions. 2 ratios set equal to each other is what we just did. So we can cross multiply to kind of solve it. 2/3 equals the exact same thing as 4/6. So if I represent it as x, I need to know what would match it to make it also represent 9 over 24. So if I cross multiply, I would get 24x, drop my equal sign into the center. 9 times 6 would get me 54. I could divide by 24 and get my answer as 54 over 24. You could simplify that if you wanted to. So proportions are basically me setting up two equations that should eventually be equal if I simplified them. So if I have equivalent proportions, I can also flip them around. Okay, so if this is my original, I could flip-flop my AB, but it means I would have to follow suit with my back end. So I flip-flop my AB. I had to follow suit with my CD then to make it equal still. Okay, I could also flip-flop them. So if I made A over C, that means my other side, I would make B over D. If I add my bottom to both sides, I could also add my bottom to both sides on the other side. So what you do to one side, you have to follow suit on the other side to keep it equal. Okay, so if I start off as AB equals 3 over 4, I flip-flopped. So to follow suit on the other side, I need to flip-flop. So 4 over 3 would make it equivalent. Okay, similar polygons. Similar polygons are polygons with the same shape, but they might not be the same size. Okay, so if you look at these 3 examples, they are the exact same shape, but they're not the same size. One is bigger, one is smaller. Okay, polygons that aren't similar are examples of these, where they are not the same type of shape. If you notice, this one is way fatter at the bottom than this one. Okay, it's not the exact same shape, just scaled to be the exact same size. If I double something, all of my sides will double the exact same way. Okay, you can see that this one is way fatter when it got bigger. This one is way skinnier. Okay, so for us to say that there are similar polygons, they have to have the same number of sides. If it's a triangle, the other one has to be a triangle. The corresponding angles are congruent, so my angles have to match and my sides have to be proportional. Not the same, but proportional. So if I multiply one side and scale it by 2, so that means doubling my side, I would need to have all of my sides doubled. Okay, so first off, the way that we would write it, let's say we pick angle A. Angle A would have to be congruent in my other one to angle M. Okay, my next one, angle B, would be congruent to angle O. And my last one, angle C, would be congruent to angle N. My sides would have to be proportional. So to say that they are similar, I could say AC is similar to MN. Okay, I could say CB is similar, which means they're not the same, but they're scaling by the same thing, to NO. And my last one, AB, would have to be similar to MO. Okay, so not congruent, but now I'm using this little similarity sign. Once I say that, I could say the 2 triangles are similar. So I could say triangle ACB is similar to triangle A matches with M, C matches with N, and then I have O left. Okay, so scale factor, a ratio that compares each length in the drawing to the actual length, so we're scaling it by an actual length. So if I multiply by 3 on one side, I multiply by 3 on all of my sides to make it fatter. Okay, so I've got this little picture here. So remember, it's all written respectively in here. So A matches with W, B matches with X, C matches with Y, D matches with Z. So I can write it that way too. So B is going to match with angle X, C is going to match with angle Y, and D will match with angle Z. My sides should be proportional as well. So I've already done AB and WX. Then I did BC and XY, so I could do DC matching with ZY, and then AD, my last one, would have to match ZW. Okay, the reason that we have equal signs in this one is because it's after we find the proportion. So if my proportion, if I'm scaling them all by 2, it would be 2 equals 2 equals 2 equals 2. That means it's scaling and getting fatter by 2. Okay, so to do this, all of my angles match. They're the same figure. Now I got to check my sides. So I'm going to set up a proportion. 10 is going to match with 8 on my other one. I started with this one. I start with this one again. So 4 matching with 3. So now I simplify, or I cross multiply, to see if they match. Well, both of these are divisible by 2. So I would get 5 over 4 equaling 4 over 3. They are not scaling by the exact same thing. So I would say they are not similar because they don't have a scale factor that matches. Okay, my next one. Looks like we got matching angles. Now I check my sides. So if I pick 40, it matches with 24. 60 is matching with 36. And then my last one, 30, matches with 18. Okay, so when I simplify them all, I get 5/3, 5/3, 5/3. So my scale factor I got to figure out now. So it says it goes from LKM and it goes to RQS. So it's actually getting smaller. So if I multiply something times 5/3, it's actually going to get bigger. Anything that's a fraction that's going to make bigger than 1, so if my number on top's bigger, it'll actually make my figure bigger, and in this situation, I need my figure to get smaller. Okay, well what if I would have started with my small triangle and did 24 over 40, I did 36 over 60, I did 18 over 30, then all my answers would be 3/5. Well, if I multiply something times 3/5, I will get smaller. So if you get an answer that's 5/3 and your picture is supposed to get smaller, all you have to do is flip that fraction to get the scale factor to make it smaller. Okay, my next one here, so rectangles, so that means they got all right angles, so we're good on that. I got 15 and 20 and 10 and 12. So it looks like these ones are divisible by 5, so I'd get 3/4. Divisible by 2, I'd get 5/6. So are they similar? No, they're not scaling by the same amount of numbers. Okay, given the scale factor, find the value of x. So I'm going from A, B, C, D to here. So let's say I start with 4. He matches with that 2.4. Then I need to eventually find x. Okay, so I'm going to pick 6 as my other one, because he's going to match with that x. So I pick a known one, and then I pick my missing one. I can cross multiply, so I get 4x equals, drop my equal sign in the center. 6 times 2.4, I get 14.4. Divide by 4, I get x to equal 3.6. And then it says, find the value of x, round to the nearest tenth when necessary, and give the scale factor. So I still need my scale factor, so I'm getting smaller. So if I take 4 over 2.4, that's actually going to get me bigger, because my bigger number's on top. So my scale factor is 2.4 over 4. Okay, if you wanted the decimal of it that you're multiplying by, I could take 2.4 divided by 4 and get 0.6. So my scale factor is 0.6. To get me smaller, that's a number less than 1 that would make my figure smaller.